For this video, you're going to need your answers to the homework questions on pages 88 and 89 that I set last week. So you need to make sure you get that in front of you. So if you don't have that in front of you now, pause the video and then get those answers in front of you. Okay, so I'm going to go through these one by one. A, explain in terms of particles why the reading on the balance is the same in the two photographs in figure 3. So what we've got here is we've got these two solutions, okay, and then we pour this solution into this solution and we get this white solution here. And the question is, why is the mass the same before and after? So your answer should be that during a chemical reaction, the total mass stays the same. During a chemical reaction, the total mass will stay the same. So we've done the reaction and the mass has stayed the same. Now you might have added some more information like no gas is made, because if a gas is made, then the mass will go down. Okay, but that's because the gas escapes and you can't measure it with the balance. Okay, question B up here. Explain why a wooden log has a greater mass than the ashes formed after it has burnt. Okay, so you'll remember that last week we did an example of something like carbon, which is a solid, plus oxygen, which is a gas, will make carbon dioxide, which is a gas. So in the wooden log, you've got a lot of carbon. That reacts with oxygen in the air to make carbon dioxide gas. Okay, so the solid, which is in the wooden log, turns into a gas, okay, which means that afterwards you're going to have less mass because it has all escaped as a gas. Okay, good. All right, on to the next one. If at any point you're not sure about one of these answers, just pause it, rewind it, listen to it again, make sure you understand it. 4.4 grams of carbon dioxide forms when 1.2 grams of carbon reacts with oxygen. Calculate the mass of oxygen used. Okay, so we're making 4.4 grams of carbon dioxide. We're reacting 1.2 grams of carbon. So how much oxygen do we use? Well, it's going to be 4.4 minus 1.2 is 3.2 grams of oxygen. All right. Now, down to the numbered questions. Explain what is meant by the law of conservation of mass. Okay, so that was defined up here. So it should be that the total mass stays the same during a chemical reaction. And that's fine for the answer to number 1. Number 2, copper carbonate decomposes when heated, forming copper oxide and carbon dioxide. Explain why the mass appears to go down if this reaction is carried out in an open crucible. So an open crucible, all that means is it just means an open container. All right, so you do the reaction without a lid on the reaction. So let's imagine we're doing copper carbonate, CuCO3, solid. You heat it up, it decomposes to form copper oxide plus carbon dioxide gas. So the reason the mass goes down is because you make a gas. So we can say mass appears to decrease because a gas is produced. All right. Now the next question asks us, you can see it up here, 1.03 grams of copper carbonate. So if I've got 1.03 grams copper carbonate forms 0.66 grams of copper oxide. calculate the mass of carbon dioxide made. So how much carbon dioxide am I going to make? Well, the law of conservation of mass means that the mass can't change. So the amount of carbon dioxide must be 1.03 minus 0.66, which is going to give you 1.03 minus 0.66, 0.37 grams. And finally, explain in terms of particles why the mass of the solid increases when copper is heated in air. So, in this one, what's happening is I'm going to heat some copper up, okay, and it's going to react with oxygen in the air to make copper oxide. Now, that equation is not balanced. So what I'd like you to do now is to quickly pause the video and have a go at balancing that equation. Okay, so you should remember, we did this in class. If you can't remember, you'll need to go back and look at the class where we did this. We said, I've got here 1 copper. Here I've got 2 oxygens, that's what the little 2 after the O means. And here I've got 1 copper and 1 oxygen. All right, so I've got 1 copper here and 1 copper here, so that's fine. I've got 2 oxygens, but only 1 oxygen here. Now I can't change the number of oxygens inside the box, I can only add more boxes. Okay, so now I've got 2 oxygens, 2 oxygens, but here I've got 2 coppers and here I've only got 1 copper. So I need to add another copper here. And now I'm balanced. 2 coppers, 2 coppers, 2 oxygens, 2 oxygens. So I've got 1, 2 coppers. I've only got 1 box here, so I just leave that. And I've got 2 copper oxides, like that. So now my equation is balanced. All right, but back to the question. Explain in terms of particles why the mass of the solid increases when copper is heated in air. Okay, so the reason is, we say oxygen atoms from the air what do? Well, they combine with the copper to add to the mass. Okay, so you can see that in terms of solid, I started off with my copper and I ended up with my copper oxide. So the solid has increased by all the oxygen atoms that I've added on. So I've still got my original copper over here, but now in terms of my solid, I've also got my oxygen atoms from the air. All right, so any of those questions you're not sure about, just pause the video, go back and watch them again.